Chapter 2, Section 4, we are looking at problems involving rates, ratios, and proportions. A ratio compares two numbers. And it might be written as a fraction. It might be written with a colon, or it might be written 2 to 3. A proportion is two equal fractions. Two equal fractions. And the cross products property, or means extremes, is if you have A over B equals C over D, then you can cross multiply. A times D equals B times C. And we're going to use that idea to solve these next proportions. Cross multiplying, you have 2y equals a negative 40. And if you divide both sides by 2, then you have y equals a negative 20. Cross multiplying, 27 equals 5w. Dividing both sides by 5, you could have 27 fifths equals w, or you could write that as I think that's 5.4 equals w, whichever one you prefer. Number 3, that will become x plus 10 equals 96. When you subtract 10 from both sides, x equals 86. Number 4, we have 35 equals, careful when you cross multiply here, becomes 4 times g plus 3, and you need to distribute 4g plus 12, and when you subtract 12 from both sides, you have 33 equals 4g, and when you divide both sides, how about 23 over 4? You can either leave your answer as 23 over 4 or 5.75. Either one of those would be fine. Number 5, the ratio of faculty members to students at a college is 1 to 15. So I sometimes like to write here faculty over students, and I'm going to abbreviate those. And I do that to remind me where this number goes. That is students, so that is going to go on the bottom of the fraction. And then when you cross multiply, you have 15x equals 675, and 675 divided by 15 is 45, and that means there are 45 faculty. 6, the ratio of games won to loss is 3 to 2. And again, I'm going to write won and loss. If a team won 18 games, how many did they lose? If they won 18, that needs to go on the top. And if you cross multiply, you have 36 equals 3x. And dividing both sides by 3, then x equals 12. and that would mean you had 12 losses. A scale is a ratio between two sets of measurements. Ratio between two sets of measurements. And a scale drawing or a scale model just that uses a scale to represent an object. Like a scale drawing of a house would represent the whole house. So we're going to use proportions for these. Designer is trying to make a replica of the Washington Monument. If the scale is 1 inch equals 12 feet. So this is on the model, and this is the real thing. 1 inch on the model is 12 feet on the real thing. The monument is 225 feet tall. So how tall would the replica be? When you cross multiply, you have 12x equals 225. And dividing both sides by 12, you end up with 18.75. So that replica would be 18.75 inches tall. Number 8, contractor has a blueprint for a house. So 1 inch on the blueprint is 3 feet on the house. If the wall on the blueprint is 6/5 inches long, how long will the actual wall be? When I multiplied this, I would do 3 times 6 divided by 5, which would be 3.6 feet equals x. So that wall would be 3.6 feet long. A rate is a ratio. Sorry about that, wrote that wrong. A ratio with different units. Ratio with different units, and it might be something like dollars per hour. It might be something like students per class. It might be something like miles per gallon. Many different options. And a unit rate has a second quantity of 1. So the unit rate is always, the unit is 1. Corey earns $52.50 in 7 hours. Find the unit rate, or how much he earns in 1 hour. So we do 52.50 divided by 7, and that ends up with 7.5. So he makes $7.50 per hour. Number 10, Kobayashi of Japan ate 53.5 hot dogs in 12 minutes. Find the unit rate, or how many hot dogs he ate in 1 minute. So 53.5 over 12. And if you divide that, he eats 4.45 hot dogs per minute. 4.45 hot dogs per minute. And converting rates, we're going to change from one rate to another. Change from one rate to another. So if we start out with 325 miles per hour and write it like that with the miles on the top and the hours on the bottom, and we want to change that to feet per minute. So first of all, from miles to feet, there are 5,280 feet in 1 mile. You'll notice we have miles on the top and miles on the bottom. And then hours, 1 hour is 60 minutes. And whenever you write these down, you need to make sure a unit on the top cancels with 1 on the bottom, and then hours cancels with hours. And then we have 325 times 5,280, and then I'm going to divide by 60 minutes, and that is 28,600 feet per minute. Number 12, 52 feet per hour, and we want to change that to inches per second. First, from feet to inches, there are 12 inches in 1 foot. Feet on the top, feet on the bottom, cancel. And then we need to go from hours to minutes and minutes to seconds. So in 1 hour, there are 60 minutes. And then in 1 minute, there are 60 seconds. Hours cancel, minutes cancel. And then if we do 52 times 12 divided by 60, we get 0.173 inches per second. Cyclist travels 56 miles in 4 hours, and we want that in feet per second. Miles to feet, there are 5,280 feet in 1 mile, and our miles cancel. We need to go from hours to seconds again. So 1 hour is 60 minutes, and 1 minute is 60 seconds. Hours cancels with hours, minutes cancels with minutes. And when we divide that out, let's see, 56 times 5,280, and we're going to divide that by 4 times 60 times 60. I got about 20.53 feet per second. And the last one, a cheetah can run at a rate of 60 miles per hour. And we want this in feet per second. So 5,280 feet in a mile. 1 hour is 60 minutes. And 1 minute is 60 seconds. Miles cancels with miles. Hours cancels with hours. Minutes cancels with minutes. And you end up with 88 feet per second.